Okay, moving on to example number 4. So we have radical 2x minus 1. So again, we want to work with what is on the inside of our function. So we are going to let u be equal to the 2x minus 1 because that is what's being raised to the power here. We are going to let du be equal to 2. That is the derivative of what's inside. Okay. I'm going to go ahead and show you how to make that shortcut. So du is equal to 2 dx. So that's just going ahead and putting the dx on the right side as opposed to starting with it on the left side like we did on examples 1, 2, and 3. Okay. So in this case, okay, when we go ahead and start to rewrite our new integral, okay, we would have the integral of, okay, this is our u. So we have u to the 1/2 power. Okay. We don't have anything else. So when we are looking at what to do with our dx, that's all we have. So we need to get rid of the 2. So we are going to divide both sides by 2. So we would have du divided by 2 is equal to dx. That's the substitution that we need to make. So the dx here is going to be substituted out for 1/2 and then du over here. Okay. It is acceptable, and some of you may enjoy actually putting the 1/2 out in front of your integral. So 1/2 the integral of u to the 1/2 du, especially when we start to add in bounds and then we're integrating from one thing to the next thing. Okay. We're at the point now to go ahead and take your antiderivative. So the antiderivative from u to the 1/2 would be u to the 3/2. And then we're going to multiply that by our inverse of that exponent, which would be 2/3. Okay. We then have 1/2 still out in front, so you're going to cancel out those fractions. So the 2's are going to cancel. So my final answer would be 1/3 u to the 3/2. Okay. Go ahead and plug your u back in. So final answer for example number 4 would be 1/3. And then we would have 2x minus 1 to the 3/2 plus c. Okay, and that is our final answer for example number 4. Yep. Let's move on to example number 5, which is the trig function. Trig functions are probably the most popular way that you'll see a u substitution. I also find them to be the easiest to recognize when you see a u substitution problem. So we have the integral of sine of 3x. Okay. I will oftentimes right away go ahead and write this as a squared on the outside and then cosine of 3x dx. So you'll see what I mean. I wrote the squared on the outside of the sine. Okay. So whenever you see a double trig function, okay, these are really easy to set up because you're going to do the same thing every single time. You are going to let u be equal to the trig function that is being raised to the power. So you may want to jot that down in your notes. Okay? So the u is equal to our trig that is raised to a power. So that is super important. Okay? So in this case, my u is going to be equal to the sine of 3x. Again, not squared. We never raise it to that power squared. We're always just raising it to that power. Okay, so sine of 3x. Okay, so then what is our du? So this gets a little bit tricky. The derivative of sine is the cosine of 3x. Okay, but we do have a chain rule involved here. So the cosine of 3x times the derivative of what's inside, which is a 3. I'm going to stick that out front. And then we do have that dx tacked on at the end of that, okay, because we're doing it with respect to x. Okay. So when we look to make our substitution now, okay, here is our u. Okay, so our new integral is going to be the integral of u squared, right? Okay. So let's look and see what we have. On the outside, we have cosine of 3x dx. So we actually almost have everything here that we need. All we have to do is get rid of the 3, so I'm going to divide both sides by 3. Okay. So I divide both sides by 3, and I'm going to end up with a 1/3 out here in front, and then du. Okay. So really easy integral here now to do. A problem that looks ridiculously complicated becomes super simple. Okay, so I'm going to antiderivative u cubed over 3. Okay, I still have my 1/3 out there. So my answer for this problem is going to end up being u cubed over 9 Make your substitution back in, and we would end up with sine of 3x all to the third power divided by 9, and then I end up with plus c. So here is my answer for problem number 5. Okay. So that takes us to our last example, which is example number 6. Okay. Example number 6, we have our first fraction problem here. So we have negative 4x over 1 minus 2x squared, and then that quantity is squared dx. Okay. So if you look at what we have written down here, you can kind of assume where you're going to start. Again, you're going with what's being raised to a power as your u. So u here would be equal to 1 minus 2x squared, the thing that is inside the parentheses. That's always where you start. Okay. So our derivative of u with respect to x, what is the derivative of what's inside here? Well, we have negative 4x, okay, and then dx. A really easy start, okay, because we have that negative 4x up on top. We can see that written right there, so that's going to make life really easy for us. So we're going to go ahead and make our substitution right now. So we rewrite our integral. We would have the integral of 1 over u squared, okay, and then our entire thing with our negative 4x dx is going to be replaced up here, so that's going to become our du. So all we're doing in this problem is just taking the integral of u to the negative 2 du. That's an easy antiderivative. Remember, we are adding 1, so this is going to be u to the negative 1 divided by negative 1, so negative u to the negative 1. So my answer for this problem would be negative 1 over u, which would equal, when we sub back in, negative 1 over, plug in your x terms, 1 minus 2x squared, okay, and that is now to the first power, so no exponent, and then plus c. Okay, so that is my final answer for example 6.